Bismillahirrahmanirrahim. Assalamu alaikum. Today topic is the frequency modulation. In frequency modulation, only the frequency of the carrier wave will be changed, not the amplitude. If this is the modulating signal which is going to modulate, and this is the high frequency signal carrier wave, and when this signal is modulated on this, so we can see this is the highest amplitude. Highest amplitude in this portion, the frequency of the carrier wave will be very high. As we are moving towards the lower point, the frequency of this will be very low. When at this point, it will become F naught, that is the resting frequency of the carrier wave. At this point again we will achieve F naught. In between both F naught, the resting frequency, this is the minimum of the amplitude, and here the frequency of the modulated signal is very low. Now again at this peak, the portion of this peak from this to this, the frequency of the modulated waves is very high. At this region, the frequency of the modulated wave is very high. So you can see, as the frequency of the modulating signal is high, then the repetition of this carrier wave will be high. And when the frequency is going downward, so the frequency will be low. So it means you can see that the amount of change of the frequency, how much amount of the change depends upon the amplitude of the modulating signal, and the rate of change. And the rate of change means how fast the change of the fast frequency packet of the highest frequency will become. It depends upon the frequency of the modulating signal. If these cycles per seconds are very high, then the repetition rate of this modulated signal is high. If the cycles per second is low, then the rate of change of this modulated signal will be low. This is the modulating signal carrier wave, and this is the modulated signal. So from this description we have obtained 2 points. So these 2 points are, we can write this. Number 1, the amount of change in frequency is determined by the amplitude of the modulated signal. Modulating signal. And the other things which we have obtained, the rate of change is determined. The rate of change is determined by the frequency of modulating signal. So these 2 points are obtained from the figure which we have described before, that the amount of change in the frequency, how much frequency will be changed. It depends upon the amplitude of the modulating signal and the rate के कितनी मतलब बार बार वो हाई फ्रिक्वेंसी हो रही है सिग्नल की, that depends upon the frequency of the modulating signal. So the frequency of the modulated carrier increases. Frequency of modulated carrier increases as the amplitude increases. Obviously it is the same working. ऐसे ही होता है, जितना एम्पलीट्यूड इंक्रीज करेगा उतनी ही फ्रीक्वेंसी उसकी ज्यादा हो जाएगी, बट डिक्रीजेस as the signal amplitude decreases. Okay. So the highest frequency at point, the highest frequency age, when we have got the packet of the frequency, the signal amplitude is positive and it is very high, and at the lowest frequency, when the minimum of the amplitude is coming, then what happens like this, if it is a signal, so we can achieve this here the high frequency at this signal. This is very high signal, mean very high signal in this amplitude, and it will be lower, mean the frequency is lower. At this point we got F naught, that is the resting frequency, and at this is the low minimum. And again when this maxima is occur, then what happen, the frequency of the modulated signal is very high at this point and then low. So this is the highest value, here the highest value, here is the lowest value, and F naught is the resting frequency. So resting frequency means when the amplitude of the modulating signal is 0. When the amplitude of modulating signal is 0, then it is called the resting frequency. ठीक है, that is F naught. Resting frequency is indicated by F naught. So in this article we have concluding with the 2 points. One point is the amount of the frequency deviation depends on the amplitude of the modulating signal, and other is the rate of frequency deviation depends upon the signal frequency. Thank you very much.